Okay, guys, so we're going to finish up our chapter on proteins with a little bit of practice problems with our last section. So go ahead and try these on your own. They require a little bit of more complex thinking. They're not necessarily just like, what's exactly the answer? We're not spewing back answers right now. So try them on your own, see if you can figure them out and work through the answers. And then I'm going to go through the answers now. So the first problem says methanol and ethanol are oxidized by alcohol dehydrogenase. In methanol poisoning, ethanol is given intravenously to prevent the formation of formaldehyde. Part 1 should be super easy at this point. Draw the structures for ethanol and methanol. So we have ethanol and methanol. Would ethanol be a competitive or non-competitive inhibitor of methanol oxidation? So the overall structure of methanol and ethanol look very similar. So that makes me already believe that based off of the properties of competitive inhibitors, that it would be a competitive inhibitor. Second off, there's, well, let's write that down. Point number 1 is that they have similar structures. And then point number 2 is that we're told that we add extra ethanol to prevent formation of formaldehyde. So if we are adding extra of a substrate, then we are able to change how that equilibrium occurs or how that binding occurs. In this particular case, and before we were talking about like when an inhibitor binds, it completely doesn't react. In this case, it still reacts, but it forms something poisonous. So we're trying to outcompete that. So so because we're adding more ethanol, to outcompete, so because of these two reasons, it's a competitive inhibitor. Okay, continuing. Whoa, sorry, y'all. Okay, continuing on. Second problem. Trypsin, a peptidase that hydrolyzes polypeptides, functions in the small intestine as an optimum pH of 7.7 to 8. How is the rate of trypsin catalyzed reaction affected by? So first one is changing the pH to 3. So we're told that the pH of for this particular enzyme it has an optimum pH of 7.7 to 8. So if we change the pH to 3, we are significantly changing the amount, what the charges are on the amino acids. So if we're significantly changing those charges, you probably are going to denature the protein. Therefore, you see no activity. So you greatly diminish that activity is another way of saying it. Running the reaction at 75 degrees Celsius. So in our particular case, we're not told what the optimum temperature is. However, we are told that it's in the small intestine of a human, or it doesn't say human, but we can assume it's our small intestine. So our body temperature around our whole body is at 37 degrees Celsius. This is significantly higher. So we're probably going to denature the protein because we're adding way too much energy into this protein. So denature the enzyme. So probably no activity observed. Okay, which of the following describe non-competitive inhibitors, enzyme inhibitors, which describe competitive inhibitors? So we're just trying to decide if it's competitive or non-competitive. So the first one, the inhibitor has a structure similar to the substrate. So that is definitely a property of a competitive inhibitor that binds to the same active site. We have the effect of the inhibitor cannot be reversed by adding more substrate. So we know that in competitive inhibition, we add more substrate and we can kind of flush out the inhibitor. But this says you cannot do that. So that is a property of non-competitive inhibitors. Sorry, guys, I've just sneezed. Okay, the inhibitor competes with the substrate for the active site. So that's pretty much where we get the word competitive inhibition from. So this is definitely competitive. The structure of the inhibitor is not similar to the substrate. So in competitive inhibitors, we have a similar substructure, so it binds to the same active site. Non-competitive, it binds to a different active site. So this is definitely non-competitive. In our last one, the addition of more substrate reverses the inhibition. So again, this is going to be a property of competitive inhibition because in order to kind of just flush out all of the rest of all of the inhibitor, you're competing, having 10 people competing for one chair or 10 people on one team competing against one person on one team is going to help increase that activity. Okay, those are all of our practice problems, and that's where we are, and that's what we're learning about proteins.